G'day and welcome back. This is another radio I picked up on the way back from Melbourne. I got this in northern New South Wales. It's a HMV 888. I think it's about 48 or something like that, be around that time. And it's from a deceased estate of a radio technician. I'm not sure what he was. Someone had bought it and then I've bought it off them, and they told me they got it from a deceased estate. It's quite a handsome looking radio, and the finish on it is brilliant. It's better than anything I've ever done. It's like glass. I don't know what he's done there. It's really good. So it's in really good condition cosmetically. The dial glass is all right. I believe it's got short wave as well as medium wave. And apart from a few little bits of missing paint, a little bit of a scratch behind there, it looks pretty good. It looks presentable. So I think this will clean up okay. I've zoomed back a little bit. You can see it's got all these marks on the top. The young lad I bought it off said it had been in a shed, so I don't know what it is. It's from insects, I think. I think that'll come off all right. That won't be a problem. I'll spin it around. I'll have a look in the back. I haven't had a look at this at all. I brought it home last night and put it on the bench, and I've just brought it in and mounted it here. As I said, it's an 888. I did look at that. There's some alignment instructions, which is pretty unusual to print on the back. Pick up speakers. It has provision for 3 separate speaker outputs. It's plugged into the small. There's what's that say? External and large. Okay. Oh, what's that? That's the tuning cord. Now another thing that I can see is this is a 6V6 GT, and it's electro harmonic, I think that says. They're normally black. This is brand new. I can see Russia there, made in Russia. Huh, okay. There's a 5Y3 and that looks brand new as well. So someone's had a really good shot at this. I'm not sure if the knobs are the correct ones or not. I can't find any photos on the internet. The grill cloth is a bit of calico or something, so it's quite loose. Yeah, I'll see if I can find something better than that. The young fellow I spoke to said he'd plugged this in, he didn't get anything, like it didn't work at all. So I've plugged it in, we'll try it out. We'll go for broke, eh? We'll see what happens. No current flow. Volume switch. Oh, there we go. Oh, still no current flow. All right. Dicky switch maybe. It's not making any difference. I wonder if the bloke that restored it's put in a fuse. Alright, I'll have to take it out of the chassis and have a look. I've taken the chassis out and I've turned it upside down. I think I may have stumbled across the problem. It appears to be centered around here. There's a big black area here, and these wires are all burnt. Now ground zero appears to be here. These are wires coming through from the transformer. I don't know what wires they are. This is a choke, this black thing here, but it's burnt here. It hasn't burnt all that off, so I don't think the wire was overheating. This is just from the burning. This one's burnt, and there's some wires further back even that are burnt. So this must have gone up with a real bang. I'll turn the chassis over, see what the other side of that looks like. Here's the top side, and here's the wires going through the grommet, and you can see the flash mark up here. Look at it, it's huge. So this must have been really impressive when it went. I'll take the cover off the transformer, I'll see how much damage is inside. I've separated the clamshells there, and it's barbecued, this transformer. It's just look at my fingers. It's barbecued, look at it. So that transformer is no good. I'll see if I've got another one. Here's the power supply circuit for the radio. This is the primary. It's got multiple tappings, doesn't really matter. We're going to run it on about 240. There's 5 volts there for the 5Y3. There's a center tapped secondary there. And of course the heaters, so that'll be 6.3. Here's a little voltage chart for the 5Y3, and it's got 290 on one side on one plate, and the second plate's got 290 of course. So if I can get a transformer that puts out around about that with the radio running, that'll be okay. A couple of volts either way is not going to really worry it. So I'll go out in the shed and have a look and see what I've got. I think I found a donor. This is mounted horizontally, but that might really matter. It's a bit of a hybrid set. It's got some of these Novell valves in here as well as some of the old octals, so it would no doubt be a 5Y3. There's no brand on this radio. It's a no brand name, so I don't know what it is. I can't look up any of the specs. I'll turn it over. We'll see what's on the other side of this transformer. Here's the underside of the transformer. It's got one of these plates on it. 5 volts there, 2 amps, so that's the rectifier. That'll be ground, I assume. Earth, yeah. 285, so yeah, might be a bit low on the voltage. That'll be 285, and that'll be the center tap going straight to ground. That'll be 6.3 across there. So I'll take this one out. I'll take the other one out. I'll try and work out where all the wires go. Now it looks like this panel here comes out and you've got a power supply. So I've disconnected the 2 or 3 wires that go off into the set from underneath. And I think if I undo these half a dozen screws, that whole plate with the transformer and the capacitors should come out. And this is the last one. Oh, there's a screw there. So if I can get this one out, this should be it. There's a wire I missed there, that's the neutral going in. That one I got. So hopefully it'll come out. Okay, so that might come out now. Stuck to the speaker. Oh, there's 2 wires there. They're going to the external power supply there. I'll see if I can undo those. Okay, I'll try again. I undid the screws holding that in, so we're out. Alright, I can tell you this absolutely stinks. Oh my god. That's all glued itself together. Whatever. Oh wow. Yay, look at that. That has been roasting in there. Ugh. This is the new one I'm going to put in. It's so much bigger. I didn't even think to look how big it was. Oh my goodness. So we're going to have to do a bit of work there. I'm going to clean all this mess up. It's everywhere. I'll throw this outside somewhere. I may have to rewind that, and I don't want to, but I may have to. It's been about a month and a half since I last looked at this, and I've tried to buy some spare transformers, but they've all been so big. This is reasonably small compared to all the other ones of about the same era. So it looks like I'm going to have to rewind it. I'll take this out in the workshop to pull it apart. It's going to make a mess everywhere. I have an idea to add something to my winding machine that might just make it a bit easier to get more even windings. Alright, I'm at the workshop. I've got a bit of paper here. I'll have to remove these, I think they're I's and E's again, and then I can get the center winding out. But before I do that, I'll show you something I've been thinking of. On our trip back from Melbourne, I had a bit of a thought. I'd seen people controlling stepper motors, and a friend of mine did a very quick video, and he didn't give me much detail, but he came up with this. This is an old inkjet printer. On our trip back from Melbourne, I was thinking, I had a lot of time to think, why not use an inkjet printer that's already got the mechanism going back and forward. It's got a little drive belt and it's got a stepper motor. So if I can take over control of the stepper motor, I can make it go back and forth. Give me a minute, I will try and dismantle this and I'll get the mechanism itself out. I bought what's left of the printer inside. This is all I've saved. This is the print head here, and it just runs up and down this rail. There's the motor there, and I was mistaken. I thought it was a stepper motor, and it's not. This is just an ordinary DC motor, and they just swapped the polarity to get it to change direction. And I thought maybe I'd use this one, drill a hole in it perhaps, and I can feed the wire through there, and it'll just run back and forth. My original plan was to use software and direct the motor back and forth and limit it and speed and all that. I can't do it. I haven't got enough time to play around with this. I will eventually change this over to a stepper motor and use some software to control it. But for now, what I'm going to do is put some switches on here, and the carriage can hit the switches and reverse the motor for me. And I should be able to control the speed with the DC voltage. I've connected the motor to some wires that are going up to my DC power supply. So I'll turn some power on. Oh, there you go, 2 volts it started moving. I'll swap these over. And we'll make it run the other way, I hope. There we go. Yeah, alright. So I'm going to go to the shop and buy some little micro switches, and it can hit a micro switch, flip a relay, and change direction for me. This is not going to work anywhere near as well as I originally hoped, where I was going to time it to the winding machine and get it to do it using software. But this will do in the interim. I want to get this transformer wound, and I'll just do a quick fix, and it should do something. It should be better than me trying to feed it on. I've thrown together this little controller out of parts I had in my drawer here, and it's got a speed control here. This is a voltage regulator here. There's a little latching relay, and I'm going to use that to latch the movement back and forth. So when it hits a switch, it'll latch in one direction, run the carriage one way. It'll then latch it in the reverse direction, and it'll go back the other way. So I'm going to give it a try out. We'll see what happens. These two wires here will be the switch, and this is the power supply, so I'll touch one of those or the other, and it should reverse the direction of the motor. Alright, I'll put some power on. I'll go for 12 volts, that's what it's designed for. Wherever it is, there it is, come on. Oh, whatever, that'll do. Nothing's happened. I haven't tried this yet, so I don't know what's going to happen. Hey. Oh. That's cool. Oops, the wrong way. As I said, this is a speed control, so if I turn it down a bit, it'll... Yeah, it won't even work. If I turn it... Whoa! Oh, of course it latches. Ah, so that's sitting there with power on it. Whoa! That's going to be too fast. Now these are the switches I was going to use. They've got a nice long lever on them, so they'll actuate fairly easily with little force. I'm not sure if this is going to have enough strength to move it. There we go. Oh yeah, that's easy. Okay. I've put the carriage down the other end again. I've dropped the voltage a little bit. I'll see if it'll move. No, it still works it. Okay, so we might have enough power there to just run up and down with the wire in it. Now, of course, that's still trying to go, isn't it? Yeah. Alright, I'll take the power off. I'm going to make up a wooden frame, and it can sit on that. I think the switches will mount probably at the back, and I'll mount them down on a piece of wood, and I can move them up and down a little bit. I'm not going to get too advanced with this. This will be a very temporary setup. When I left this before, I really wasn't happy with it. By the time I dropped the voltage enough to get it to go slow enough, there was not going to be enough power in there, enough torque to run it. So what I've done is taken the motor out of the little roller that runs the paper in and out as it prints, and this is it here. I've cut it off. Well, I've cut off the other end actually, and I've mounted it upside down here, and I've connected it on top of the other motor. So here's the original pulley. This is the stub that I cut off the long roller. It used to be about 30 centimeters long. And then I've put it together with hot glue, and I've bolted it all together, so it actually works pretty well. So I'm going to demonstrate how it works. I've got to be really fast with these two wires, otherwise I'm going to run it in the end, and it's now got so much torque it'll just ruin itself. So I've got power on, there we go, and so that's how it works. I've got a fairly high voltage selection there, so it's got tons of torque. Then my main concern is this joint here will fail halfway through, but we'll see how that goes. So I'll go and quickly knock up a frame for it and mount the switches, and we'll see if it really is going to work. I've mounted the carriage on a block of wood, and I'm about 3/4 of the way through what I'm doing. I've gone overboard as usual. Originally I was just going to just screw this down to a block of wood, put some screws into the micro switches and just set them once and forget about it. And of course that really never was going to happen, was it? I was going to thread the wire through the end of this plastic bit here, and I thought it's going to be hard to get in from underneath, so I've made it so it flips up, and now I can just feed the wire through there. Now, as I said, I was going to screw these switches straight onto a piece of board, but I've actually put it on with a thread there, and you can adjust the throw of the cradle. So I've still got to do the other side. Now the reason I've got a little overboard is the board that I was going to mount this on has a big crack through it, so I broke it and glued it back together, so I had a day or so while the glue set. Also, after I'd put this mod on, I played with it a bit more than I showed on the film there before. This is very controllable. You can slow it right down. So this may be a permanent solution, and I may not bother with the stepper motors. I'm not doing transformers every day. I've still got a fair bit to do. I've got to mount it on the board. This needs to be finished, put some electrics on it. Once I've done all that, I'll take it inside. We'll look at it inside. I've pretty much finished this. I've got it inside now. Here's the cradle. I've mounted the micro switches here. And there's the control board mounted as well. Here's the micro switch adjustment. If you wind it in and out, you can move the position of the micro switch here. Now, as I said in the workshop, you can lift this up, thread the wire through, and I've put a little friction device here to put some tension on the wire when it winds on. This mechanism's got a spring on the end to hold it one way or the other. And at the back here, there's an adjustment for raising and lowering the feed onto the coil, so you can allow for it as it gets bigger. There is one minor snag. It doesn't work very well. I did a few test runs, and this is the biggest one. It tends to bunch at the end and be very thin in the middle, so I could have wound it better than that. So I really haven't gained anything by that. And the real problem is that it's too fast. It runs too fast. Even at the slower speed, I've got to have the machine running at such a high speed, it can't even see what it's doing. And it's still too fast. It sort of wraps it like that instead of running it on. It wraps it across like that. I'll show you how it works. This is the motor connection here. I can turn that off. I can turn both of them off actually. And then there's a center control switch. This one's for the carriage. So I'll leave that on, put the master on, and it should start running. Now, as you can see, that's pretty slow. That's about as slow as I can get it without it stalling. Yeah, there you go. So that's about as slow as I can get it. It needs to be much slower than that. If you can imagine this spinning and that winding on that fast, it's nowhere near good enough. So if I put both of those on and the master back on, it's kind of close but no cigar. And I can adjust this micro switch in and shorten the throw. I'll do the same on the other side. So it works pretty well, but it's no good. But I do have a better idea, and it's over here. Oh, hang on, that's my lunch. Oh, cheese and Vegemite, nice. And here it is, it's a stepper motor. So I've actually been learning how to use this, and it only took about 3 hours to set it up and get it running, write the code. Yeah, it was pretty easy. I should have done this in the first place. The stepper motor and the controllers that I'm going to use are from Arduino. Arduino, I think it's like Raspberry. My son bought an Arduino kit. I think it was about $40 online on eBay, and it contained everything. It contained all the controllers, breadboard, remote control, wireless, whatever you wanted to do, you could do it. And it was all in the one kit. It was a big box full. So he's given it to me, and I'm going to use some parts out of it, and then I'll just replace them as I go along. And when you buy the kit or the parts, and my local electronics shop has the parts too, they sell all the Arduino stuff. You don't get any information with any of it. There's a book available, there's lots of information online, lots of people writing code and doing little projects, so there's plenty of support there. So if you wanted to get into this stuff, it's pretty cheap and it's good fun. Here's the old DC motor I removed, and here's the gear off it. I've taken that off. Here's the new stepper motor, and this is the board, the control board, and this is the driver board for the motor. So the motor plugs in here. So this board here is the program board. This holds the program that controls the motor, and it controls it through this board. So this board actually drives the motor, delivers the voltages. This is the one that tells that board what to do. I'll just put a bit of tape on the end of the shaft there so you can see it. And if I plug this in, it should start running. There it is, and there's the little LEDs that gives you the 4 voltages going to the motor. So there you can see it going back and forth. I can't remember what I programmed it to. I've just been playing with the program. So it looks like it's doing almost a turn, and almost a turn then coming back. Now you can adjust the speed, you can adjust where it starts from, you can adjust how far it goes and how far it goes back and forth. It's pretty much universally configurable. The only limitation is the speed. This little motor is pretty highly geared. I think it's 64 to 1. So it's pretty highly geared. But I think that'll be okay. I think that's as fast as it goes. Anyway, I'm going to make a little adapter for this shaft for this pulley, and I'll put that on. We'll see what it does. I mounted the stepper motor in the original tray, and I had to make up some spaces here, and I made an adapter for this pulley to sit on. So I'm going to give it a try. So I'll plug the motor into the driver board here. I haven't changed the program. I have no idea what this is going to do. Oops. Oh, look at that. Now that, I think, is maximum speed. I think. That's great. I'll be able to slow that way down if I need to. So that means I'll be able to wind the wire on at a more intelligent speed instead of ludicrous speed like I was doing before. I'm going to put the tray back on. I took it off so I could drill the holes for the motor. It's time to give this a test run. I've modified the code to do what I want. Now I'm going to thread this wire through here. I'll flip that up. I need to undo the friction device. That should just swing out of the way. And feed the wire through a little guide there. Through the friction device. There we go. And just do that up again. Okay, just fold that down. I have a bobbin here. I've been testing with this a fair bit. So this is probably about test number 5. Now this isn't a very good test, but anyway, it's the best I got at the moment. Here's the code I'm using to control it, and there's the speed. So that's the speed that the little carriage will travel, and that's the distance it'll travel, 280. I played with that a little bit to get where I want it. So all I do is punch that and it uploads to the controller. There we go. So the program's now in there. If I turn this on, this should travel up, hit that switch, stop, and then it very slowly comes back until it hits the spot that I want to travel. So that's where it starts from it. So it shouldn't hit the switch again. It'll push it a bit, but it doesn't operate it. If I push this reset button, it'll do that routine again. And that gives me a chance to wind this wire on, and then I hit the switch over here. So it's not perfect, but it's not bad. But I'm going to live with that at this stage. This whole thing needs much more development. But it should get me out of trouble for this transformer. It's getting a bit late now, so I'm going to pull this, at least pull the core out. Look, there's a wedge in there if you can see it, and they use that to finish it off to keep the laminations tight and to keep the coil tight. So if I can get that out, so I'll see if I can drive it out. It should come out. And there it is there. Alright, oh, that's charcoal. It's a bit of wood. So now these should just about come out. In fact, there's one there. There you go. I think these ones are just baked onto the coil. Right. There's another one. It gets easier, of course. I think these have all glued themselves together. I'm trying to work out the pattern here. This one came out and it had 2 of these to 1 of these. So I don't know what's going on. Anyway, I'm going to keep pulling this apart. I'll work it out as I go. I'll come back when it's pulled apart. Now I'm going to unwind this old coil. I don't need it. I've got a new former. I've got new wire. I want to count the windings just to make it easier for myself. I could calculate it, but I'll use this as a reference. Now there's 4 big wires here, so there's 2 heavy windings. One will be 5 volt and one will be 6.3. I'm going to try and measure these. I scraped the enamel off so we're back to the actual wire and not measuring the coating. What's that say? 1.06 mil, 1.07, 92. So you would think this will be 92, 96. So I'm guessing those two wires are the same and these two are the same, or the same coil. Now the number of turns I pull off will tell us which is which. Now here on the sides there's 2 there, and there's 3 there, and that's the bottom. So yeah, that's probably the start of the primary, and these will be the 3 or so tappings that I had for the various voltages, and this one here will be the center tap, and the one of the secondary with the center tap, but one of the wires is missing. So I need to make sure I bring the wires out at the same side, and well, actually these will all be one side, won't they? And these big ones will be another side. So yeah, okay. I'll mount this in the winder and I'll count the turns. Okay, I've mounted it in, and this is the start of one of the windings. So I'll bring it around there, zero that. And this, I need to be careful because this will just spin because there's not much in the middle. Okay, I've come to the end there, so I'll bring that around, and there it is. So that's 39. So winding 1, 39 turns, and I think it's about 1 mil. So that one's there. I'll bring that to the front. I'll zero that again, and I'll do it again. Alright, there we go. And we've got 31. So that has less wraps, that'll be the 5 volt. So winding number 2 is 31, and that's 1 mil. Okay, there's the next one. There's some wire there. So I assume this is the primary, I think. So I'll zero that again. Alright, it's very fine. Oops, that's the end of it. Oh, is it? Yeah, that's the end of it. Oh, I've hit the end of it. I think that's the secondary. It's a lot of turns. Yeah, about 18. Yeah, that's probably the secondary. So the primary must be the one on the bottom. So we've got 1805 there. So winding 3, 1805. And there's a bit here. I'll just measure it. I reckon it's about 15. 0.13. Now, I've been writing which side of the coil it came out of, so I think that was left hand. It sort of all happened at the last second. I've lost the wire here. I forgot to put the camera on, so I've reset the counter here. I started pulling at it again, and the wire just broke in here somewhere, so I'll find it. But what I said was that we should get back to 1805 or whatever it was, probably within 10 or so, because I did lose a couple of turns here and there. There it is. So just wind it back a couple, and I'll start again. I'll come back when I get to the end. Anyway, that's going to go to 1805. Pretty sure. Something close to it. Oops, I've lost that. What have we got there? Oh, well, so 1800, we'll call it. Okay, good. So that's centre tap there. Then we've got winding 2, and that's 18, well, whatever, doesn't really matter. It'll be around there, and that came out of the, I still don't know, I think the left hand. I've cleaned this off a bit, and look, there's all these broken wires. So I'll reset that. How am I going to do this? So there's one length. If I keep the lengths, I can work out how many turns there were. I don't know where that's going. There's another length. Yeah, this is all falling apart. That's in the top. think. Yeah, breaking off everywhere here. Another one, another one. This wire here is going the right way, so I think it's starting halfway through the coil. But it won't matter too much. This should be a short winding because this will be the difference between, I don't know, 230 volts and 250 or 220 and 240 or whatever it is. So it should be a fairly short winding. That just broke off, so that might be the say the 230 or something winding. Now all these broken wires that came out, they're all the same length. So they're one wrap around that coil. So if I just add those up, which I've got, what, 4 there, 5, 6, 7 I think, 7, maybe 8. So I'll just add 8 turns to that. Something like that. So we'll say that first winding may have been 66, I'm not sure. I'll have to punch all this into the calculator, it'll work it out for me. Then we got 66 maybe. So I'll call that W4. Not sure what I wrote there. That should be winding 4. This should be winding 5. What was I writing there? Alright, there's a lot of wires hanging off this thing now. I had, oh there we go, I finished that one. I'm just counting the numbers now. Look at that, that's all welded up in there. Yikes. Just as a check, I'm really just using it as a checks and balance if you like. Alright, I finally got it all off. What did I get? 1347. So I've changed winding 5 to 1347 and out the right hand side. So I'll go and plug these numbers into the calculator and see what it comes up with. I've fed the info into the calculator. This is a new sheet I made up. The other one was a mess. Now I've got the new winding numbers on here, not the old ones, but I do remember them. There's the original there. These are the primary. I was originally just going to do one winding for the 240 volts, but I'm not 100% sure of how accurate anything's going to be. So I'm going to put the original windings back in for the 3 voltages that came with it. I think it started at 200 and went to 250. So there's the original primary that I got roughly when I unwound that coil. These were 1805 and these were 31 and 39. So they're all the same. That one's gone down by 2. Here's the calculator. I've entered the data as I said before. The calculator comes from a chap named Marko Delac. He has a website and some YouTube videos. I'll leave a link below to one of his videos or his website, and you can purchase this for, I think he charges $10. I have my mouse just up the top here, left of center, and I've got 230 volts in there. That's the mains voltage. I put in a range from about 210 to 240, I think, to give me different primary turns so I can do the tappings as I go through. I've got 290 AC volts for the secondaries, and there's a 5 and a 6.3. I got the 290 from the service manual for the radio. I also got the current, 5 volts and 2 amps for that 5x3. There's the 6.3. I calculated the current adding up all the heater currents and the bulbs that it uses and came up with 1.4. When I did all the calculations, this was 1805 and this is 1804. 1804, the 5 volt, it says here 31, and it came up with 31, and the 6.3 is 39. So what do we got there? 39. So it worked out exactly right. I'm printing off a new bobbin now, and once that's finished I can start doing the winding. The bobbin has finished printing and it's come up pretty good. Now I've made it in 2 parts, so these are exactly the same either side, except one's male and one's female, so they just snap together. I'm going to put some glue on there, some super glue, and that'll hold it. This is quite happy with super glue. As you can see in there, I've printed it out of ABS. ABS should withstand up to 100 degrees before it even starts getting a bit soft. If the transformer's greater than 100 degrees, I think we're in trouble. I'll super glue these 2 together and then I'll clamp it in the winder. I've mounted the bobbin in the winder. I've made some changes to the way this operates. I did show you the other day that it comes along, hits the switch, and then starts its travel. Well, that was okay if you wanted to start winding from this side, but I wanted to start winding on that side sometimes. So if you look on the little pad here, it says come out the right hand side on some and left hand side on the other. So I've reprogrammed it into a left and right configuration. I just have to reload the program into the chip there and it'll just do what I need. I'll show you what it's going to do. So I'll turn it on, and I've also wired the motor in. So when it starts the motor as well. I was trying to do it manually and it was a bit hit and miss, but it should work now. This will go up the end here, stop, put a buzzer on. I've got 5 seconds to make sure the wire's in the right place, and it all starts running by itself. Now I've got a spool of wire. This is the right gauge. So if I bring that out, something else I did was put little bits of foam here so that when the machine stops, this roll does just keep going. So that seems to work all right. I've got a bit of heat shrink here, and I've run the wire through it. We'll put a bit of tape on there to hold that. I'm also going to run masking tape all the way around, mainly to just get rid of these edges here. They're a little bit sharp. I did file them, but I'll just cover them up, just give it something soft to rest on. And I can pull back on the spool a bit. I'll put a bit of tape around the wire that's running free there. Now I better reset it. I don't want to forget that. Now this is going to run through its program. I will hold this over here till it starts, and we should be right. So I push the reset button, put some power on over here. So it's hit the stop there, and I'll just wind this on. Yep. Here we go. Right, I'm just about to run out of wire. These spools aren't big enough. I can't get a big enough spool of the right diameter. So we only got halfway there, 561. But it's come out pretty good. It's nice and firm on there. Very good. Yeah, it's not like factory, but gosh, it's not bad. I've put a join in. It's got a heat shrink on it. It's got 2 layers of Kapton tape either side of it, so that shouldn't be a problem. Now I did want to put a pause switch in here to cater for this occasion, but I didn't get around to it. So I'm going to have to do this manually. And there we go. Well, I've run out of wire again, and what are we short? 56 or something turns. Alright, I'll have to change the wire again. I'll be back in a minute. Okay, ready to start off again. Now I've got 1312, I needed 13.7. That's okay, I'll just wind a bit off. Alright, I've finished that. I put another joint in. I've got up to 1307. Now what I'm noticing is it's building up more and less down here. So I'm going to move the micro switch along a little, and that'll mean it'll stay there longer and a bit less time down here. So let me pull that out. I'll run a wire out the side here. That'll be our first tap. I've run the wire out, and of course it's a double. I haven't cut it or anything. So it's just a loop out of the transformer. And I'll tape that down, and I'm ready to keep going. The next tapping I need is 1431. Okay, so there's the buzzer. We're ready to go. I need 1431. Push the wrong button. Anyway, that looks good. I'll take that loop out and I'll come back. Next up, 1524. So I'll just get this ready to go. There we go. There you go, 1526. I'll put a bit of heat shrink across there and take this wire out. I can cut this wire. Alright, I've put some tape just across there to hold that. What I'm going to do is take it outside and I'm going to cover it in varnish. I'm going to try and get as much varnish in there as I can to stop it vibrating. It's nearly dinner time, so I can let that dry for an hour or so. I'll come back and then we can put on the next couple of windings. It's the next day. That varnish took much longer to dry than it said on the packet. It's electrical varnish. It's not just, you know, household varnish, so it's designed for this purpose. But I got right in there. I really soaked it in there, so hopefully it's got through most of that. I've mounted the next bit of wire, which is the secondary. This is 0.15 millimeter, so much thinner than that. The other one was 36, I think, 0.36. So I've set it up and I've loaded the program into the module, the Arduino module, or the controller, and it's set to do a start from this side now. As I just said, it comes out the left-hand side for this one. This is the speed I've set the program to, 2400. This one here, the first one I did, the primary, that was 13. And the faster you go, the lower the number, which is counterintuitive, but it's actually the number of delays between each step on the motor. So the more delays you have, the lower the speed. So this has got 2400 delays, so it's much slower. Okay, I'm set up. I've got the wire right in the corner there as far as I can. I've pulled this over a little bit so it's ready to go. I'll hit the reset switch. It's reset. It's going to come back very slowly. The buzz will go. I've got 5 seconds to get that right and we should start winding. This is not going very well, is it? So we're looking for 1804 here. We've got a way to go yet. Looking for 1804. Oh, there it goes. Alright, good. Wow, that is really good. That is really, it's nice and tight. I was worried it was going to break the wire. Now this is tending to build up on this end now, so I need to move the micro switch the other way. I moved it a bit too far last time. That'll do. Okay, that's really nice. That is really nice. The speed wasn't right, but it doesn't really matter. It just fills itself in. So I'll wind that back and I'll take a tapping out there. I took this off, took it outside and painted this again with some varnish, soaked it right in, put it out in the sun and it dried in half an hour. It was a bit cold overnight, so it took a while last night. But I'm ready to go again. So once again, 1804 we need, so I'll reset that and I think we're okay to go. I'll put some power on it and I'll do a reset and that will start the program. And I'll just pull that wire tight. I put a new spool of wire on. There's the buzzer. So I've got 5 seconds, but it'll go now. No, I missed it again. 1804 was what I was going for. 1815, I'll just rewind it again. That looks really, really good. Now, it wasn't winding exactly the way it should have, but I didn't worry about it. It's such fine wire, it just fills in. But golly, that looks great. So that's the secondary finished. I'm going to hand wind the other two for the 5 volt and the 6.3 volt. So once again, I'll take this off, take it outside and soak it in the varnish and let it dry off. We'll come back and I'll do the other two windings. I did soak that again in varnish and it's dried. It dries pretty quick in the sun. I need to put the 5 volt winding, and the 5 volt winding is 31 turns, and it's 0.96. I don't have any 0.96, I'm using 1 mil. So this has got to go on the opposite side of these ones here, so it goes through these holes here. So I guess I'll go there. Marko's calculator tells you how many turns per centimetre. This is 1 mil, so obviously it's 10 mil. So 31 turns, it's going to come out to about 31 millimetres. So I've put 2 marks there, that's roughly 31. I'm going to run it down the centre of the spool here, so I'll rotate here. Pull it tight, and I'll just line it up with that mark. Alright, so let me get it set and I'll start winding. Alright, I've reset the counter and I've got 1 wrap on there. I put a bit of tape to hold that first little bit as it goes through the side of the spool, and I'll just do this by hand. I've done 4 wraps already, 5 wraps now, so not far to go, 26 or something. Alright, I'll do this, I'll come back when it's finished. I just realised I'm supposed to go out the right hand side with this wire, not the left. Doesn't make any difference, but I'll do it now before I get too far. So when I've finished all that, I'll come back. I've put 31 wraps on there and it's gone further over than I should have. It's got fairly large gaps in there. You just can't pull it over tight enough, so that's a lesson there. So I'll demount this, take it outside, put some varnish on it, and I'll come back and do the final winding. This is the last winding. This is the 6.3 volts and it's going to be 39 wraps. Now technically this should just make it across to the other side, but as I found out, you can't get it tight enough to, you know, get what it says. So even though it's 1 mil thick, it'll sort of take 1.2 mil each time because there's a gap. So I'm going to try, but I don't hold much hope. I'm having a bit better luck using this scraper here, and I've just kind of shaped it so that it can push on the wire. It won't hurt it. It's plastic, so I'm actually able to get it pretty tight. So it's working pretty well. Maybe I will get the 39 wraps in one layer. So I'm just coming up to 39 now, and I didn't make it. It all sort of fell apart at the end where it went in the hole where the previous winding was. So yeah, it just kind of didn't really work as well as I liked. Anyway, it's still pretty good. So there's our 39. I've got to turn that around, go out one of these slots here. I'll just hold that there while I try and get a sharp edge on there, or reasonably sharp. Alright, I'll cut that and feed it through the hole. I've put some wire through the bobbin there just to hold that one. Now I can take the bobbin off and I'll go and coat this in varnish. That's all done. I really soaked this again with varnish and got it into all these slots in here. It ran out the other side, started running out around here, so it really got inside. So I'm pretty happy that that'll be trouble free. Now my plan was to pull these wires in again, which I've done, put a coloured wire on it and then take it back out again. But of course I've closed the end off here when I printed it. So what I'm thinking of doing is snipping it, which I've done there. I had to do it there, I couldn't get it in. I think I can snip it. I left them there for strength, but I don't think it needs it. I think it's okay by itself. Something I forgot to mention was after each winding and between each winding, I put 3 or 4 layers of Kapton tape in, this stuff here, to insulate the winding. So there's no high voltage winding next to a low voltage. There's like, you know, so just say about 4 layers of tape in there to keep it insulated. Now this tape's temperature resistant and chemical resistance, it's everything. So there's no chance of it shorting out. So I'll go out in my workshop there. I'll just cut these slots out here so that they go all the way up, and then I'll start wiring in the coloured wiring. I've mounted the coil back in the winder. It's a bit easier to operate from here. I downloaded this from the internet. This says black for the primaries, so that's what I'm going to use. So what I'm going to do is put some black wire through here, join it up with that one, put some heat shrink on, and then run the wire out there. I need to remove the enamel from the wire, so I just use a knife to scrape it off. Now wrap the little wire around the big wire there. Good soldering there. I'll put some heat shrink on. There we go. The gentleman that provided the calculator has a video on doing this, and I'm pretty much following what he did, so credit to him. So that looks pretty good, I reckon. I'll finish these three off as well, the same way as I've done that one, and then I'll do the secondaries. Alright, these have come up nice, so they're going to tape down like that. They'll be very nice. This one here is the centre tap for the secondary, and the other two secondaries, of course. So the colour coding for the secondary is red, and the centre one's red and yellow. I haven't got red and yellow, so that'll make orange. So perhaps I've got an orange wire, I'll use that. So once again, I'll scrape it off. I did try burning it off, a bit of this wire, but it didn't seem to work as well. So I don't want to make a high resistance joint there. Alright, so I'll wrap this around. I had to put a bit of tape there to hold it while I soldered it. It just kept wanting to fly back the wrong way. And a bit of heat shrink. Alright, I will rinse and repeat with these other two. I do have an orange wire to put in for the centre there. That's red and yellow mixed. So I'll put my Pericomo record back on, and I'll come back when I finish that. So those three are all done now. I might just put a little bit of tape there to hold those down temporarily till I do the other side. So these wires here are so thin I don't want to pull on them. I'll just tape them there. Okay. I've just realised I've used yellow on these. They were supposed to be red. So I'm going to put some red heat shrink on to cover those. I'm going to use yellow on the 5-volt rectifier one. I've already done that one. It's the same as what I've done with the other ones. I've got this one here to do as the yellow. These two over here are the 6.3. I'm going to do them in green. I'll do that. We'll come back and then we'll wrap some tape around it. They're all done. I've put green there, yellow there. Pretty sure I got them right this time. So just a matter of taping them down. Okay, I'll just put another wrap around on this side as well, of course. And that'll do. Alright, I'll take it out of here and we'll have a look at it. Alright, all finished. And I'm pretty happy with the way this has worked. So these have to go down here. No, they don't. They go down there, like that. And come out the holes in the bottom of the camshell. So the next thing is to put the laminations back. Now it occurred to me I should check the continuity of these coils. This is the secondary, so that's the center tap there, and this will be the other side, so it should be about double that. That's fine. Here's the 5-volt yellow. It should be almost a dead short. Yep. This one's the 6.3, so this will be almost a dead short as well. Yep, 0.24. I've got this connected to the common. Here are the three tappings. These should get higher as we go along. 34. 38 and 41. Okay, terrific. So I can put the laminations in, and what I've done is laid them out so I can just take one from each pile. This is such a confusing setup. So we'll start with one there. Now that one goes there. Then it has one there, and one there, and so on. So then when I get to the end there, I come back and start again. So I think that should be okay. I should be able to keep track of what's going on. Now that's the first one. I can't put that there because it's got nothing to hang on, so I'll come back later. So that one goes in there. And that goes on top. This is the weirdest setup. That one goes there. And that one goes on there. And that one goes in there. That one goes there. Oops, got two. And that one in there. Alright, so that's it. Rinse and repeat. So I'll sit here and do this for the next half hour, and hopefully I can get them all in. So when I've got them all in, I'll come back. I've got all the laminations in, and I've temporarily put the screws in. It's got to have the covers on, of course. I just want to be sure that it's going to produce the voltages I need, and then I'm happy to put the covers on. So I've got two 40 volts going. I'll just put it on dim bulb. Oh, it should be alright. That's what you would expect, about 4. Dim bulb. Yep, perfect. What I've done is use double-sided tape to glue these little connectors to my bench, and I've got the wires running in. So this is 6.35, there's the 2 secondaries and the center tap. So I'll put the meter on AC, and 6.3 you would like to see maybe about 7 odd or so. 7.1, 5 volts. This is unloaded, of course, a bit over 5, maybe 5.5 or something, 5.6. Now for the secondaries, I'll go right across the start. I'll leave the center tap out for a second, and we've got 660. So half of that is 330, and half. So we should have half. Yeah, so 330. Yeah, and 330. Perfect. I say perfect, when it's in the set it'll be a different reading, of course, so hopefully it'll come out where I need it. But I'm happy to now put the covers on. There's the 2 covers there. I have cleaned them up. It took a little bit of cleaning, gave them a good sandblasting, put a coat of paint on it. They look good, they'll be ready to go back on. But I'm going to leave all the covers and everything till next week. I don't even know if the radio works. I don't know why the transformer blew up, whether it was just a fault with the transformer or there's something else in the radio that caused it. I'll just do a quick overview of what I could have done or what I should have done, or improvements I can make to this winder here. One of the things that'd be good if you could move this right up close to the coil so there's less chance for just wandering off by itself. That's a bit hard because you've got the outer sides of the coil spinning around, so you've got to keep away from that. But I could have got a bit closer. One thing I will do is cut these off if I continue with this idea. The original concept was to make a very cheap machine to do this sort of thing, and I used an old printer which cost me nothing, and I tried to use the original motor, which would have worked if it wasn't so fast. If I kept gearing it I could probably do it. In the end the stepper motor was only $10, and that included the driver board, then a cheap Arduino kit which I already had, so it really didn't cost me anything to get this far. So if I was doing this again, I may not bother with the printer. You can buy a stepper motor that has a Acme screw thread on it, and that would just reverse and run a nut up and down as you need it. So you wouldn't need any of this stuff. You do need some sort of guide. Now I've designed this so I can adjust the height of the guide to allow for different diameter spools and whatever I'm doing. But of course if you do that, this micro switch actuation point changes. So the micro switch needs to be mounted up on the same plane as the guide here. If I was starting out and I didn't have one of these, I wouldn't buy one. You can get a bolt or something from the hardware shop and put it in some bearings. You'd have to make something up, and just mount a stepper motor right on the end of it so that it just drives it directly. So I reckon I could buy the 2 motors, the controller, the Arduino kit and micro switch. I reckon I'd do it under 200 Aussie dollars. These things are about 130 Aussie dollars, so you're halfway there already. So what you save on that you can put into making a good one. Anyway, I'm going to continue with this. I will put a stepper motor. I've ordered one, so I'll put a stepper motor on here, and I should get a much better result next time. Next week I'm going to clean up the radio chassis, get all the burnt wiring out, and put it all back together. We'll see what happens when I put some power on. Now I apologise for getting sort of sidetracked on doing rewinding of a transformer. I hope it was helpful or beneficial to people, and I hope you can join me next week for my HMV Transformer Rewind Radio Adventure.